Okay, so today is the third video in the series on blockchain technology. On blockchain technology, and today I'm going to give you a little intro to Polkadot, which we're going to be delving into. Polkadot is it's a cross-platform project, so a cross-chain project rather. So their big focus is on allowing different chains to share data, to move things back and forth. As they say, allow cross-chain movement of data. So right now you have like Bitcoin, the Bitcoin's block. It's one block. You can't move data between Bitcoin and Ethereum, two different chains. And the purpose of these cross-chain projects, and Polkadot isn't the only one, there are others. The purpose is to allow data to move between different chains, different sorts of things. Now I did look at the original white paper, and it's several years old, so I didn't put too much time into that. I sort of glanced at it. They have an excellent website at, I think it's Polkadot .network, and I'm going to put a link to there on the in the description, because that is going to give you a ton of details, and we're going to be delving into it. Now, there are several different kinds of components in a blockchain. So you have the connectivity, you have the consensus, and you have the governance. So connectivity involves several different types of items. You have the relay chain, which is the main chain in Polkadot, and that allows all the other chains to connect. And off that chain, you have parachains and parathreads. Parachains, people can actually like lease a slot in the relay chain, and so that's over time. The parathreads are like transaction based, and this is how the data moves. You also have bridges, which allows the parachains and the parathreads to talk across each other without having to go back to the relay chain. The other part of it is consensus, which is how you determine what is a valid block. So in Bitcoin, you have the 51% say the block is this, it's this. They're more on it. Polkadot's more on a 2/3, but they have different items that are involved in that. They have the nominated, they call it nominated proof of stake. So you have nominators who send stake to various nodes that nodes that they trust. The validators are the nodes that do the validation. They stake because that's a way of, it's proof of stake. And also that gives them a way to penalize them if there's anything nefarious going on. Collators. Now this is interesting. Polkadot has what they call a sharded model, which means you can have a transaction and it can be in several different nodes, which allows things to allows for greater expandability of the chain. Allows it to get bigger over time and still, work properly. Similar to a sharded database, if you're familiar with something like Hadoop, where you split the data between different shards. It makes things faster if you set it up properly. You might set things up based on, for example, how you search on that data. But the example they gave is, I'm trying to remember the example, where you can have different parts of, let's say, a real estate transaction on different nodes, and they don't have to maintain all the information themselves. The collators, which is part of the validations, they collate the shards and sharded transaction to produce the validation proof. So they do, validate the shards that they collect. There's also a concept of fishermen, and that could be a validator. I mean, they monitor for bad behavior, and it's reported to the validator. That could be the collators. I think it may be other validators as well, but we'll get into that more later on. And that's the way they did, prevent bad behavior and keep things running smoothly. Now, there's also governance in any of these projects, and there are two types of governance. You have the council members, and they represent the stakeholders, the passive stakeholders. And then you have the technical committee, and they represent the people who are active. They're the ones actively working on Polkadot. So you have those two groups of stakeholders, if you will. The token is DOT, and it's used for connectivity. Staking DOT is how a parachain leases a spot on the relay chain. That's one way DOT's used. DOT's also used consensus by both the validators and the nominators. The stake keeps the validators honest because they can be penalized if they do something wrong. The nominators use their stake to nominate the nodes they trust. It's also used for governance, and those who hold DOT are involved in the governance process, as I mentioned before, the council members. One of the last things I'm going to get into in this introduction is the two big algorithms for validation and for mining. I'm just going to mention them briefly. There's a lot there. The first is the validation, which is called GRAMPA. Yeah. Ghost Recursive Ancestor Deriving Prefix Agreement. That's a mouthful, but it basically is the nominated proof of stake algorithm that's used to validate the nodes. And then there's BABE, which is the mining algorithm. It's how blocks are mined. Much like, you have the proof of work algorithm in Bitcoin. So there's a lot there. There's a lot of documentation, and so that'll give us an opportunity to really get into some cool stuff, into the depth of this project. I would like to eventually install some of the nodes and test them out, and I think we can learn a lot from that. I first have to figure out why my computer that I want to use to do that does not feel like talking to my network properly. But at any rate, so with a lot there, I mean, this is a real juicy project to sink one's teeth into. Very fascinating. And hopefully you enjoyed this video, and I will see you next time. If you like it, hit the like button. If you're interested in seeing more, please subscribe, and thank you, and take care.